All right, so now we are going to talk about the human digestive system, okay, or the digestive system of human body. And this series is going to be like to the point note series where we discuss about the different human physiological systems in very short span and in short span with little bit of details obviously, but in a short span of time. So let's start talking about the human digestive system now, and I'll continue to talk about the digestive system, and I'll be writing and drawing different stuffs to explain the process of digestive system, the components of digestive system, and then the structures and functions, important rules of the organs in the digestive system. So let's begin. So the very first thing that I want all of you to know is when we are talking about digestion, we're talking about digestion, and digestive system is the organs that are working together helps in aiding digestion process in us. So what is digestion? Digestion is basically a process of converting very complex food components or complex food particles. So let me take a different color. Let's take a blue color here. It's basically a process of converting complex food particles here, okay, complex food into simple forms, okay, simple form of the food. So what I mean complex means, let's say protein. When we eat something, it contains protein, it contains fat, it contains nucleic acid and so many other things, and it also contains carbohydrates, and we convert them into amino acids. The proteins are broken down into amino acids, fats are broken down to fatty acids, okay. Nucleic acids are broken down into nucleotides, nucleosides, carbohydrates which are polysaccharides converted into monosaccharides or simple form of sugar like glucose, okay. So these are the major complex foods which are known as macromolecules are converted to simpler forms. That is what digestion do, okay. And also vitamins also needed in our body for small quantity, that also can be done by this digestion process. Later at the end stage of the digestion, vitamin production is there, okay. So what happens in this digestion system is that to aid the digestion we have a system. So system, simply known as digestive system, is composed of what? Digestive is composed of alimentary canal, alimentary it contains any alimentary canal, and it also contains glands, okay. So what are the example of glands? There are different glands that are present there here which are involved in this process. We'll talk about that. And the alimentary canal is simply a tract, pipeline like structure, coming and starting from the mouth ending in anus, starting from mouth ending in anus, okay. And the glands, if we talk about, we have liver, we have gallbladder, and we have pancreas, okay. These are the examples. So these are the components of our digestive system. And this the whole digestive system starts, as I mentioned, starts in the mouth ending in anus through the alimentary canal, and different glands. When you talk about the liver, gallbladder, pancreas, there are different connectors from all these glands into the different locations of the alimentary canal, okay. And apart from this whole components and system, there is also one more thing that helps in the mechanical breakdown of food, and that is known as, let's take a different color, not blue or any blue tinge, let's take a black one here, and that is our teeth. Teeth is involved, okay. And when we talk about teeth, there are different structures of the teeth that we need to know basically. the jaw. We have this upper and lower jaw, and we have an arrangement of teeth in the jaw. Okay. And when we say we have a arrangement of teeth in the jaw, it looks something like this, a arch shaped structure. Sorry. It looks something like this. Okay. And what we have here, teeth. One. So this is how they are arranged. So the numbering, if we say 8 in this side, 8 in this side, so starting from here, 3, 4, 5. So this is 8, 7, 6, 5, 4, 3, 2, 1. Okay. Similarly, we have the same number 1 to 8 in this right hand side as well. Okay. At the very beginning, we have incisor. We have incisor 1 and 2. Incisor. Then what we have? 3 and 4. This is canine. Then what else we have? 4 and 5. So 3 is canine actually, sorry, 3 is canine. Then we have 4 and 5, which is premolar. 3 is canine, 4 and 5 premolar, and 6, 7, 8 molar. Now all these teeth, they are used for chewing of the food. You know, it's a mechanical breakdown of the food before entering into the alimentary canal. It's very, very important. But among all these teeth, we use all of them mostly, except for the 8th one, the molar one, the last one. This 8th one generally are of no use in both these sides. Okay, so it's something like the function of this teeth is not there to chew the food anymore. Probably we have the use of this teeth some point of time in your evolution, but right now we are not using it to chew the food anymore. Okay, now based on this idea of the arrangement of the teeth, we have different nomenclature. What are the nomenclature? Thecodont. The nomenclature number 1, thecodont. Okay. Thecodont are those organisms who have the teeth, but in case of humans, in our case, the tooth is kind of embedded in the jawbone. So we are looking at this arch shaped structure, which is a jawbone here, and the tooth is embedded there. So we call it thecodont. And we also belong to a category known as diphyodont. Diphyodont. Why? Because we have two set of teeth. Di means twice, so two set of teeth. Okay. Why two set of? Because at the early stage we have one set of teeth. After that, all the teeth falls and we have a permanent half. So we are diphyodont. And we have 4 different types of teeth: incisors, canine, premolar, molar. So we are also known as heterodont. Heterodont. So these are all classifying a human tooth. 4 different types of teeth, 32 permanent teeth. 32 permanent teeth are there, 4 different types. So heterodont. Hetero means different. Heterodont. Okay. And we also follow a dental formula of what? 2, 1, 2, 3. And adult teeth have a dental formula of 2, 1, 2, 3. So what do you mean by 2, 1, 2, 3? 2 incisors, 1 canine, 2, 1, 2 premolar and 3 molar. 2, 1, 2, 3, 2, 1, 2, 3. So we go something like incisors, canine, premolar, molar, ICPM. So 2 incisor, 1 canine, 2 premolar, 3 molar. 2, 1, 2, 3 is the dental formula. 2, 1, 2, 3 by 2, 1, 2, 3. Okay. So this is regarding the teeth. And why we talk about this? Because when we start the digestion process, actually when we eat something, it comes to our mouth and teeth is actually involved in breaking down that food. Generally it's strong solid thing, so our tongue helps the food to migrate and properly process it and present it towards the teeth, and the teeth is going to break it down. Okay, so what happens there, after the food enters the mouth, teeth is doing its job of mechanical breaking of food. Okay, and the tongue plays the food properly. And after that, and also in this oral cavity, in this area which is known as oral cavity, in this oral cavity also glands known as salivary gland mixes saliva, and the food content is mixed with saliva. Food components are mixed with saliva, and this is known as bolus. Food component mixed with saliva, and this salivary gland also releases carbohydrate degrading enzymes, salivary amylase, that can break down complex carbohydrates into simpler forms. So carbohydrate digestion kind of begins in the mouth, but rest of the other components like protein, fat, they start the journey later, not now. They'll start it later on. Okay. So now, after this process is done, then this food is migrating from the oral cavity through the esophagus. Look at the spelling of esophagus, Oesophagus. That is the connector between what? The pharynx and the mouth cavity to the stomach. Okay. Now the food will reach the stomach through the esophagus. Got it? And there is a structure known as epiglottis, which can prevent the entry of food into the glottis, because pharynx opens into esophagus and trachea both at the same time. So basically this esophagus, you can think about this, esophagus goes like this, and it has a wider connection here, a connection coming from the oral cavity and a connection carrying from the nasal cavity. So both are connected here. So epiglottis is a cartilaginous structure that prevents the food from entering into the glottis, because if the food enters there, it will cause problem, because our respiratory system is designed not to deal with solids but air and gaseous matter. Sometimes when we chew very fast or speak or talk while eating, we have this kind of situation where food entering into our respiratory tract, and immediately the response come out by taking that component of the food particle out of our nasal cavity with the ciliated structure that is present in the nasal passage. Okay. So now at the end it will be connected to the stomach. We'll see that structure later on. Okay. So now let's move to stomach. We'll be talking about stomach here. Okay, in this side. So after esophagus we have stomach, and what it looks like, let's take a different color. Okay, let me draw like this. Let's draw like this. Okay, and what we can clearly see here in the stomach, which is placed in the upper left portion of the abdominal cavity, and the stomach has different structures in it. Okay, what structure we have? This is esophagus. Let's take a different color to point it out. This is esophagus. OES. Okay, this is esophagus. But in the stomach's own structure, this is the first structure of the stomach, this bend. This is known as fundus. Fundus of the stomach. Then this region is known as cardiac. Cardiac region of the stomach. The rest of the portion is known as body of the stomach. And this is known as pyloric region of the stomach. At the end, when it is connected to the small intestine, this portion of the small intestine is known as duodenum. Duodenum. Okay. This is how they are organized. Okay. And now in this 4 different structures, when you talk about fundus, cardiac, body, pyloric, some cases people only talk about fundus, body and pyloric region. But here we have these 4 structures. We generally talk about the 4 structure here. And what we can tell is that this between the esophagus and stomach, there is a sphincter, a muscle layer, sphincter present, which is like a valve. Okay. And this valve opens up in one direction. It opens up in one direction. This is known as gastroesophageal sphincter. Gastroesophageal sphincter. This one. Gastroesophageal sphincter. This one. Gastroesophageal sphincter. That regulates the opening of esophagus into the cardiac position. Into the cardiac position of the stomach. So cardiac is a position where the esophagus opens up. Then we have 3 other regions: fundus, body and pyloric. Fundus is the top side, body the rest of the large portion, and pyloric is the portion very close to the duodenum. Basically pyloric is the place where it opens up to the duodenum, and there is another sphincter present known as pyloric sphincter. Pyloric sphincter. Now when we talk about the pyloric sphincter, that is another valve that is present between this pyloric region of the stomach and the small intestine. If I draw it correctly, in a proper drawing of stomach, it should look something like this. It's not always accurate when you try to draw it. It looks something like this actually. Like this. So if this is the case, then you can see this is the pyloric region. So this is where the pyloric sphincter will be present. This is where the gastroesophageal sphincter will be present. This is pyloric sphincter will be present. And this is where the pyloric region is there. And this is the small intestine, beginning of the small intestine, that is duodenum. Duodenum. Okay. So duodenum looks like a she-shaped structure. That's what I was trying to say here. Okay. She-shaped structure. And if we talk about the small intestine, it has this all this kind of rest of the structures like this. So what we can simply say, duodenum is the connector that is present between the stomach and the small intestine, the beginning of the small intestine. Okay. Pyloric sphincter is present in between the duodenum and the pyloric region of the stomach. Okay. That's the entry port of food from the stomach into the small intestine. After duodenum, so duodenum, small intestine is divided into 3 different sections actually. 3 different sections. First one is duodenum. Second one is jejunum. Long coiled, this coiled region is jejunum. Jejunum. And highly coiled structure that ultimately opens up to the connected to the large intestine. Let me, if I draw large intestine like this, it looks something like this. Structures of large intestine. Okay. So if this is the large intestine, then what we can say that the part of the small intestine that connects to the large intestine, that is ileum. Ileum. Okay. So start with duodenum, then jejunum, then ileum. Three different sections of small intestine. And at the end of, when we talk about the large intestine is further divided into three different sections here. The end part, it is rectum. Then the rest of the part is known as colon. This is, let me take another color here, it's easy to explain with a different color. So rectum, then this large part before it is colon. Okay. And the colon is divided into four different sections. Four different sections of colon: ascending, transverse, descending and sigmoid. Ascending, transverse, descending, sigmoid. Four different sections: ascending colon, transverse colon, descending colon and sigmoid colon. And finally, before that we have a sac here. Before that ascending colon, you have a small sac like structure where microorganisms are present. Okay, narrow finger like projections that are present inside, that is known as cecum. That is known as cecum, this structure when you talk about cecum. Okay, it is known as CAECUM, cecum. Sac hosting symbiotic microorganisms. And from this cecum, a vermiform appendix form. And this appendix is no longer useful for us. It's a vestigial organ. We don't use it for any purpose now, but it may have some function in the evolutionary history. Sometimes what happens here, microorganisms start to grow too much, and that generally is due to the constipation problem and construction of bowel movement here in the large intestine. That leads to appendicitis, the inflammation of the appendix, infection and inflammation of the appendix, and in that case we need to cut and remove the appendix from here. So this is the cecum area and this is the appendix area. This is the appendix area. Okay. The connector part of the appendix here is known as cecum, and the rest portion that is protruding out like a finger is appendix. Right. So this is kind of the overall organ structure of the digestive system. But apart from that, what else we need to know is regarding the cross section view of the digestive system, the wall of the alimentary canal and how they looks like. Okay, how they look like. So let's move to the next slide and let's talk about this structure. So if I draw it, looks something like, if you have a cross section of the alimentary canal, then how it should look, how many layers are present? 4 different layers. So I need to use, and the last layer looks something like this. It has finger shaped projections coming out to increase the surface area like this. So this is kind of the structure, and what we can clearly see is that it has different layers, 4 different layers we are talking about. The layer, outermost layer is known as serosa. Serosa, the outermost layer. Okay. And this is made up with mesothelium. Mesothelium cells. Then after that we have a strong muscular layer. Let's draw it like this. This is a muscular layer, known as muscularis. Smooth muscle. This is made up with smooth muscle and outer longitudinal muscles. And outer longitudinal muscles. Right after that we have submucosal layer. Okay, this is submucosal layer. It is made up with what? Connective tissue present. It contains nerves, blood and lymph. Okay. And generally this layer is glandless. No glands are found except for in the duodenum. So the submucosal layer in duodenum only contains glands. Other than that, rest of the other places of the digestive tract, the submucosal layer don't have any glands. In duodenum it has Brunner's glands. Okay. Remember that. And ultimately at the end we have mucosal layer. This is the immediate layer of our alimentary canal. Mucosal layer. Innermost layer. Mucosa. Innermost layer. Okay. And it forms small fold like structures to increase the surface area. Finger like structures known as villi. This finger like structures known as villi. Okay, and this every single villi gives rise to microvilli. Even they are further divided into more finger like structures. So basically they gives a very detailed tiny finger like projections in the mucosal layer that actually helps to increase the surface area of the mucosal layer, and that actually helps in absorption of the food after digestion in the small intestine. So after the digestion process is complete, these structures are present that actually helps in the absorption of the food. And this villi, they are filled with the connective tissue, they are filled with the blood vessels, filled with the lymphatics through which the food particles after the digestion they are transported through the blood, and also the fat components transported via the lymphatics. Okay. And these epithelial cells, they also have glands, they have goblet cells. They have goblet cells. Mucosal layer has goblet cells. And this goblet cell secretes mucus. That's why they are called mucosal cell. They secrete mucus. And this mucus is basically helping in the lubrication process. Right? Throughout the gastrointestinal canal or alimentary canal, you have this mucus production. And this mucosal layer also is glandular. That means it contains, let me write, gland. And what kind of gland we are talking about? There are different kinds of gland, like gastric glands are present. If you take a different color here, gastric gland is found in stomach. Okay. And crypts are found in villi. Crypts. Another kind of glands found in villi of the intestine. Okay. And when we talk about the different fold layers, serosa, musculary, submucosal and mucosal, these are the normal fold layer. But in stomach, as the stomach produces acid, stomach contains acid. To protect the stomach internal lining, there is an extra layer. An extra layer is present. And also an extra layer of muscle is present, oblique muscle. Oblique. Because in stomach, the grinding of food is done. This oblique muscle also helps in doing that. And apart from these, all the other glands, remember I talked about the glands, liver, pancreas, salivary glands are the part of the glands of the digestive system. Okay, so now let's talk a little bit about the glands of the digestive system and how they look like. And this is a very, very important picture actually. Glands of digestive system. And there are 3 glands we are talking about. Liver, most important one, pancreas, and salivary gland. Liver, pancreas and salivary gland. Liver is the most important one because there is hardly any metabolic process that is not involving liver, so it's very very important. Pancreas is also important because it produces two very important hormones of metabolic regulation: glycogen metabolism regulation, carbohydrate metabolism regulation, that is directly related to the growth of an organism. And in this case the pancreas is producing this, you know, insulin and glucagon hormone, and we have salivary glands producing salivary amylase that actually helps in breaking down complex polysaccharides into disaccharides form in mouth, and there are other components out there. So when you talk about liver, the biggest working gland, it is of of biggest and really weighing more than a kilogram, in fact 1.5 kilograms in adult. Okay, and the liver, how it looks like, it has two different lobes. When we draw liver structures, look, something like this, two lobes are present in liver's structure. Okay, two lobe, hepatic lobule হয়ে গেছে কথা, হয়ে গেছে। Okay, so we have liver, and the liver contains two lobes, two segments, two lobes known as hepatic lobules. Okay, they are actually made up with the cells known as hepatic cells, and basically this liver is kind of connected. So there are connective structures. Let me draw the whole structure here, it will be very helpful for you to understand. So I'll take a different color to explain this whole liver, or we can say the bile pathway basically, which contains liver, which contains a part of pancreas, gallbladder and all these things. So if I draw all this structure all together, how it looks like, it looks something like this. And there are connecting structure coming out of the liver, as well as here coming out of something like this, and it's further connected here like this with pancreas. Let me draw it with a different color. Let's say this is pancreas. Pancreas looks something like this. Okay, like a leaf like structure, pancreas. And the rest is, let me draw gallbladder also. Something like this, and the duodenum, rest of the part. Everything is connected here, looks something like this. Just the duodenum portion. Something like this. Okay, may not be technically totally accurate, but try to draw it to explain the process. Okay, so when now if you look at here, this is whole the bile pathway. Okay, these are the so this is liver. I believe we can see that this is pancreas, this is duodenum, and this is gallbladder. Okay, and you can clearly see that these liver cells, also known as the hepatic cells, they secrete bile. What they secrete? Bile. And the bile is passing through these ducts known as hepatic ducts, because the ducts are originating from the liver cells. So hepatic ducts. So the bile is transporting via the hepatic duct. Okay, and it's then stored. So this is the direction. Then stored in the gallbladder. So bile is stored in the gallbladder. But who produces the bile? Liver. Gallbladder is not the producer. Gallbladder is just a storage gland for bile. Okay, and when we, bile is needed to digest fat. So when you eat food, this gallbladder pumps this bile one little bit at a time, and it's now mixing everything in the duodenum, which is a part of the initial structure of small intestine, and the process continues. And there is another duct coming out from the gallbladder known as cystic duct. So cystic duct actually mixes all this bile and deliver it to the duodenum, and via the pathway, via the connector, same as pancreatic structures or pancreatic channel. So this hepatic duct and this is cystic duct, both of them connected together, and they are connected together known as common bile duct. This is known as common bile duct when they are tagged together, common bile duct. Then this common bile duct and pancreatic duct, both are connected together. This is pancreatic duct and common bile duct. They are then connected together, and they open where? In the duodenum. They opens up in the duodenum. Common bile duct is a short form is CBD, and when people have gallbladder stone, this stone can sometimes, if it has smaller size, it can move via this cystic duct and finally can reach the common bile duct and can obstruct the common bile duct. And when a stone obstructs common bile duct, then the secretion of the bile fail to reach to the duodenum, as a result of which bilirubin content increases in the blood. Jaundice is created. So immediately we need to insert a laparoscope and take these obstructions out, otherwise it causes immense pain and jaundice. And the process is known as ERCP, via which we can achieve to remove the stones, gallbladder stones in the common bile duct. Now, so about duct is clear, liver is clear. And now let's talk about the pancreas. So what is pancreas here? Pancreas is basically present between the two limbs of duodenum, as I draw in this picture. And what pancreas produces? Pancreas have two different roles actually. Two different roles. It has a role of exocrine secretion, and it also have a role of endocrine secretion. Endocrine secretion means hormonal secretion. Exocrine means simple enzyme. So exocrine means this pancreas produces what? Alkaline pancreatic juice. It produces alkaline juice, pancreatic juice. And endocrine secretion means it secretes hormones like insulin and glucagon. Beta cells produced insulin, alpha cells produce glucagon. Islets of Langerhans is the name of the cells that produces these hormones. Okay. So these are the components of glands, and apart from that, one more gland is left, that is salivary gland. So salivary gland can be classified. There are multiple salivary glands present in our case, in our body. We have parotid glands that are present in the cheek. So let me write it. Parotid gland, where it is present in the cheek. Then we have submaxillary. Submaxillary. Submandibular. Submandibular. Both submaxillary and submandibular are present in the lower part of the jaw. And we have sublingual. And as the name suggests, it's below the tongue. Sub means below. So below the tongue. Sublingual. So this is regarding the salivary. What happens? Salivary gland. Sorry for the bad handwriting here. Okay, these are the components. So the structure of the digestive system, the organ structures are clear, the gland structures are clear. Now we are going to talk about the digestion of food. So digestion of food can be of two different types: mechanical digestion and chemical digestion. Okay. So mechanical digestion is actually done only in oral cavity or buccal cavity, which is known as mastication of the food. Okay. And so that is the only portion. The oral cavity is the portion where mechanical digestion is done. So let's take a color. In the buccal cavity or oral cavity, buccal, buccal cavity. It occurs in buccal cavity and is facilitated by the placement of food by tongue, and teeth does the rest of the job. Tongue is involved, teeth is involved. And this is where the glands function. Salivary gland is there. Saliva secretion is involved. Mucus secretion is involved. Mucus is also produced by the salivary gland in the saliva. It helps in lubricating the food. And when the food is mixed with saliva, it is known as, remember I told you earlier, bolus. Okay, and this bolus, as it's mixed with saliva which is containing lubricant, it can easily pass through the esophagus without scratching or esophagus. Scratching it passes through the pharynx and then to the esophagus quite easily. Okay. And once the bolus reaches stomach, then the chemical digestion begins. And this movement of food from the mouth, although it's lubricated around, but they move for the movement, the whole alimentary canal has a muscular layer, right? And this muscle layer is needed for contraction and relaxation. This contraction and relaxation of the muscles, smooth muscles that are present there throughout the alimentary canal, that actually helps to migrate the food from the location it originates throughout the intestine, and that is known as peristalsis. Very, very important process. And through peristalsis, the food reaches from mouth to the stomach, from stomach to the duodenum, from duodenum to the small intestine, from small intestine ultimately the component need to be released from the body, reaches the large intestine. So always peristalsis is needed. Peristalsis is a very, very important word, a very, very important process without which multiple diseases of digestive system can originate. Chemical digestion also found in the mouth due to the release of salivary amylase, and also saliva contains many different ions as well: sodium, potassium, chloride, bicarbonate. Okay, so in the saliva we have the first chemical components: sodium, potassium, chloride, HCO3, all this. We also have salivary. Why we call it salivary amylase? Because amylase is also secreted by the pancreas, known as pancreatic amylase. And saliva also has this lysozyme. Lysozyme is nothing but a antibacterial agent that can kill bacteria if it's present in the food. Okay. So whatever complex carbohydrate that is present in the food, at the very beginning, as the saliva contains salivary amylase, it can break down that into maltose sugar, which is simpler form of the sugar. But salivary amylase requires 6.8 pH to 7 pH, near neutral pH to work. Okay, so if acidic pH is there, salivary amylase will not function. Okay, so that is the very first part of the chemical digestion. Now let's migrate to the second part of the chemical digestion, and that is in the stomach. Stomach will be the location of this digestion. Stomach stores food for many hours, 3, 4, 5 hours. And stomach also have 3 type of gastric cells. Okay, it contains secretory cells, gastric cells, 3 types of gastric cells. It has a mucous neck cell, it has peptic cell, it also have oxyntic cell, which is also known as parietal cell. What are their functions? Mucous neck cells, as the name suggests, secretes what? Mucus. Let me change the color again. Secrete mucus. Peptic cells secrete pepsinogen. Pepsinogen is a crude version of the enzyme pepsin, which can degrade and break down proteins. So it's a prerequisite form, pepsinogen. Whenever you say ogen at the end, that means they are not active form, they need to be activated. And then we have this parietal or oxyntic cell. This one secretes hydrochloric acid, HCl, and also produce Cassell's intrinsic factor, which is, let me write it, Cassell's intrinsic factor. It produces Cassell's intrinsic factor, and this is needed for absorption of vitamin B12, required in the vitamin B12 absorption. Now, why this HCl is needed? This pepsin activity is proper in presence of acidic environment. So HCl secretion is there, and generally it causes the environment of the stomach much acidic. Now, we started the food journey with bolus, where the food is mixed with saliva, reaches the stomach. Okay. And the food mixes with the gastric juice. Gastric juice contains all this, mucus, pepsinogen, HCl, everything. So whenever the food mixed with gastric juice, we call it chyme. chyme, chyme. Now this pepsinogen will be converted to pepsin, and pepsin is active in presence of HCl. HCl pH is 1.8. Very, very acidic. Just think about it. 1.8 pH. If it drops in your hand, it will cause immediate burn and damage. But it never damages our stomach lining, because stomach is protected by the mucus layer that is secreted. Now the pepsin will be active at pH, very low pH, in the acidic environment. And on the other hand, this mucus that is present, remember I told you 2 things. The bicarbonate is there, which is moving along with the food into the stomach, and it produces mucus. The mucus neck cells produce mucus. So mucus and bicarbonate, they both provide protection to the stomach lining. They provide protection to the stomach lining. Very, very important. Otherwise, stomach's acid can itself damage it, but never does. Okay. Apart from that, there are 2 more chemical. Renin. This is another enzyme. What kind of enzyme is renin? Proteolytic enzyme. That means renin can also degrade proteins. But this renin protein, renin enzyme, is found in the gastric juice of infants. Found in infants. Because they mostly rely on milk digestion. Renin is actually helpful for digestion of the milk protein. That's why they have more, generally the infants have more renin. That's why they can digest food the milk food quite easily than most of the adults. Apart from that, gastric lipase is also there. Gastric lipase. Gastric, whenever you see the term gastric in the whole digestion system, immediately think of stomach. We are referring to stomach. So gastric lipase is also secreted by the gastric glands. And what lipase does? The job of degrading lipids into fatty acids and glycerols. Okay. So we have talked about the chemicals released in the mouth. We have talked about chemicals released in the stomach. Now the last thing, the chemicals released in the small intestine. So intestine, and the gland involved is pancreas. Okay, they have very important role. In fact, most of the digestion, chemical digestion actually take place in the small intestine. So this is the very, very important one. So let's highlight the pancreas. So what else we have in the small intestine? We have bile coming in, right? We have intestinal juice, secretions. We have pancreatic secretions. Okay, all are coming into the small intestine. So this pancreatic secretions, what is present here? A lot of things. It has trypsinogen, it has chymotrypsinogen, okay, it has procarboxypeptidase, procarboxypeptidase. It has amylase known as pancreatic amylase. It has lipase, pancreatic lipase. It has nuclease, the first nuclease which is secreted here. Now this trypsinogen will be converted into trypsin, again a protein degrading enzyme. Chymotrypsinogen will be converted to chymotrypsin. They are polypeptide degrading enzymes, and they have different rules of cutting the polypeptide depending on the presence of the amino acids. Procarboxypeptidase will become carboxypeptidase. Okay. So these enzymes, these are all inactivated forms that are produced. They need to be activated before their action. Okay. Trypsinogen is activated to trypsin, as I mentioned, by an enzyme known as enterokinase. Enterokinase. And we know what is the job of kinase proteins, kinase enzymes is to phosphorylate. So kinase enzyme actually phosphorylate trypsinogen and modifies it into trypsin. Who secretes enterokinase enzyme? It's actually secreted by intestinal mucosa cells. Intestinal mucosa. Okay, and trypsin will do the job of degradation of protein. And remember about the bile. What is bile? It's just a pigment. It contains two things, bilirubin and bilivardin. Also has lecithin. That's a separate idea. Lecithin is there, but it has bilirubin and bilivardin. What are these? These are bile salts. Bilirubin, bilivardin is there, which are pigments. These are not salt. These are pigments. That is, these things can add color. Along with that, they have bile salts. What is the job of bile salts? Bile salts emulsify fat into smaller droplets so that the fat digestion can increase. Because if we break it down into smaller fragments, more surface area will be produced, so digestion will be easy. It also produces cholesterol and phospholipid. These are all present in the bile. Bile itself do not contain any enzyme. Remember that. If anyone asks you what enzyme is secreted and present in the bile, say no, bile do not have any enzyme. It has pigments, bilirubin, bilivardin, it has bile salts, it has cholesterol, it has phospholipids. That's it, no enzymes. So the bile overall helps in breakdown of fat molecules into small droplets or small micelle like structures. We call it emulsification of the fat. So what these bile salts do, emulsification of fat, and that helps in the fat digestion. Okay. And apart from that, there are cells present in the mucosa known as brush border cell. Remember, I told you earlier that the mucosal cells are generally filled with glands. So in intestine, those mucosal cells, intestinal, again let me write mucosa. Remember, intestinal mucosa here produces enterokinase. Same intestinal mucosa here, they have two different type of cells, brush border cells and goblet cells. Brush border cells and goblet cells. Okay. So they produce what? Intestinal juice. They produces intestinal juice, which is also known as succus entericus. Succus entericus. Simple terms, intestinal juice. And what this intestinal juice contains? Dipeptidase enzyme. Because peptide digestion, protein digestion begins in the stomach. So finally here is intestine. Dipeptidase will break down even dipeptides, means 2 amino acid sequence into single amino acids. Okay. It also contains lipase enzyme. Again degrades lipid into fatty acids and glycerol. It contains nucleosidase enzymes. Again degrade nucleic acid, DNA, RNA into nucleosides. It also contains maltase, because recall at the very beginning in the mouth where the food is mixed with saliva, saliva also produces salivary amylase that breaks down polysaccharides into maltose. So that maltose is still there present, and the food converted to maltose will reach its intestine, and here the maltase will convert the maltose into even further simpler form of the sugar. And throughout this intestine, so these are the components secreted by intestinal juice. I mean, they are present in intestinal juice. So finally, the whole intestine is also being protected by mucus and bicarbonate. It protects the mucus. And as they have a little bit of alkaline environment of 7.8 pH. So the pH of the stomach is very acidic. 1.8 is the pH, optimum pH for pepsin to work, and which is provided by the HCl secreted in the stomach. So again the stomach lining is protected by the bicarbonate and mucus layer. Intestinal mucosa also protected by again that mucosa layer itself is containing mucus, and it has this pH of slightly alkaline, that is 7.8 pH. Okay, and that provides the protection. Now what kind of digestion is done here? Okay, so we have talked about the different secretion from different glands of the digestive system. Now we will be seeing the chemical digestion of the food here. Dipeptides are digested by the dipeptidase enzymes into amino acids. Okay, basically dipeptide means two amino acid connected together with peptide bond. Dipeptide enzyme cleaves that into single amino acids. Maltose can be converted by maltase enzyme into glucose and glucose. So maltose is basically a disaccharide converted into monosaccharide glucose. Lactase is an enzyme acting on lactose, converting lactose into glucose plus galactose. Sucrase is another enzyme acting on sucrose, converting sucrose into glucose plus fructose. So maltose, lactose, sucrose, these are all disaccharides. And those disaccharides are converted into monosaccharides by maltase, lactase and sucrase respectively. Nucleotides converted to nucleosides by nucleotidase enzyme, and nucleosides are converted to sugar plus nitrogenous bases by nucleosidase enzymes. And di and monoglycerides, which is generally obtained after the fat digestion, are converted into fatty acid and glycerol by lipase enzyme. We'll be seeing that in a moment. Alright, so you have a clear idea about how the digestion process takes place. The chemical digestion of different components are discussed. Now I am going to talk about the next step, that is, once the digestion is complete, the chemical digestion is complete, the substances will be absorbed where? In the different locations of the small intestine. So duodenum is the place where all the gland secretions are mixed, but the absorption will be done in the jejunum ileum. Absorption will be done in the jejunum and ileum. And undigested or unabsorbed, so there are two. So the food after the chemical digestion has the two different fates. Digested food and unabsorbed. Absorbed and so digestive or absorbed food, they are done in the jejunum, ileum. Jejunum and ileum is the place where they are absorbed. Unabsorbed one will take entry into the large intestine. Entered into the large intestine. In the large intestine, basically water absorption take place, mineral absorption take place, okay, some drug absorption take place, and it secretes mucus. Mucus is also required in the large intestine for the peristalsis, smooth movement of the undigested material. Peristalsis process continues the muscle contraction and relaxation. So this undigested and unabsorbed food at the end will form what? Feces. Okay. Feces. And that can enter cecum of the large intestine. And there is a valve. Remember that there is a valve present between the small intestine connecting to the cecum of the large intestine, known as ileocecal valve. Ileocecal valve. Valve means single direction flow. It prevents a backflow because these are undigested, unabsorbed material. We should not have a backflow of this into the small intestine. Now it will be temporarily stored in the large intestine for some time till defecation, and then defecation will continue. Now this whole process of digestion we talked about. The whole process of digestion, the secretion of hormones, the secretion of enzymes, everything, they are under the regulation of hormone. Okay, hormonal regulation is there. Okay. Now, when we talk about this absorption, so this line is clear. Unabsorbed material take the journey through large intestine, should not revert back, so we have ileocecal valve, everything is clear. But what about the absorbed and digested food? So the food that are digested properly, it needs to be absorbed. The end product, which are simpler forms, amino acids, glycerols, fatty acids, nucleosides, right? They need to pass through the intestinal mucosa into the bloodstream or lymph in the small intestine. That's why small intestine creates all these villi and microvilli, this kind of structures, okay, like this. And if we zoom into one of these villi, it has further microvilli structure like this. Try to understand. So this is a kind of structure that we see. Zoomed version will look something like this. Okay, so the movement is either simple diffusion or facilitated diffusion. Okay, simple diffusion of glucose, amino acids and electrolytes like chloride ion, sodium ion can have a simple diffusion. Facilitated diffusion is for glucose. Glucose also can be transported by facilitated diffusion, or amino acid transport by facilitated diffusion, where they require the help of carrier proteins for transporting this large chunk of molecules like glucose, amino acids. And they also involve active transport. Okay, for amino acid, glucose, electrolytes like sodium. Generally electrolytes like chloride has a passive diffusion, okay, but most of them here active diffusion is there for amino acid, glucose and sodium ions. So this is regarding all the ions and components which are polar or can be water soluble. But what about fatty acids and glycerol? Fatty acids are insoluble in water, can't be absorbed by the blood because blood has maximum water component. Okay, so what happens to the fatty acids? They gain from droplets. So what happened to fats? Totally different approach need to be taken. So we are talking about digestion, absorption of fat. So again, small droplets will be formed, known as micelle. And this micelle moves into intestinal mucosa, where small proteins attach to these fat droplets and known as chylomicron or chylomicron. So is micelle again associated with the protein component, small protein coating the fat globule known as chylomicron. And as now the protein is kind of covering, so let's say this is the protein layer and the fat is present inside, that is chylomicron. Now as the protein is soluble, fat is not facing the polar region of the blood, so it can be transported through the blood. So generally after digestion, primarily the fat components are transported via lymphatics. But here if you want to transfer the most of the fat components, obviously they need to be coated by the proteins. Chylomicron need to be formed and then transferred. So now what are the absorption process from the mouth till the anus? So absorption for in the mouth, what happens in the mouth? Certain drugs are absorbed in the mouth, oral absorption. Sublingual drugs, the tablets which need to place beneath the tongue. Stomach absorbs what? Stomach absorbs water. Simple sugar, very simple sugar can be absorbed by the stomach. Alcohol is also absorbed by the stomach. Alcohol absorption can also be seen in the stomach. While in small intestine, digestion is completed and final products of the digestion, that is glucose, fructose, fatty acid, glycerol, amino acid, all will be absorbed. And what about the large intestine? Large intestine absorbs water, minerals, and some kind of drugs. Okay. And finally, the components which are unabsorbed will be forming feces and will move out through the rectum. Okay, so this is a simple idea about the digestive system. Now we will conclude it by discussing some of the digestive system disorders. Disorders of the digestive system. And you've heard about all the digestive system disorders we are going to discuss. Jaundice. What happens in jaundice? Yellowing of the skin and eyes due to the higher bile production, bile pigment, that is bilirubin. Okay, and the jaundice can be caused several reasons, due to the problem of liver, as well as problem with liver can cause that, or CBD stone can cause that. And most common type, the inflammation of the intestinal tract. Inflammation of the intestinal tract can be of for many different reasons. Can be of for eating something, for stress, mental stress, physical stress, accident, injury, infection. All these things can cause inflammation to the intestinal tract. Okay, that may lead to diarrhea, vomiting, pain, and all this. Okay, so let's talk about vomiting. What is vomiting? Ejection of the stomach content through mouth. Generally the movement of food from mouth to the stomach, intestine, and through rectum outside. So this is the single direction flow, but from stomach it can have a reverse flow, that is known as vomiting. Okay, it's controlled by the medulla, and you have a feeling of nausea. Then we have what? Indigestion, very common. Indigestion can be caused for many different reasons. Any reason which ultimately causes improper digestion of food. It's feeling fullness in the stomach. That may be due to, sometimes when you eat food, the food remains for a long time in the stomach, or our stomachs fail to producing enzymes that will degrade the food. So enzyme production inabilities or less enzyme production can also do that. Anxiety can do that. Food poisoning can do that. If we overeat, that can do that. Spicy food can do that. All these things. Okay. What else? Constipation. What is constipation? Feces are retained in the colon, is not coming out as often as it required to. Irregular bowel movement, that is constipation. The opposite of that, diarrhea. So what happens in diarrhea? Reverse of constipation. In constipation, the feces is stored in the colon for a long time. It's hard passing of stool, and the irregular bowel movement. While in diarrhea, the bowel movement frequency increases and liquid feces start to form due to much more water, less water retention by the intestinal mucosa and more water present in the intestinal lumen. That may be due to some drug related effect, that may be due to bacterial infections or viral infection, that may be due to some kind of toxin, enteric toxin. Okay, that causes diarrhea. And what happens in diarrhea also? Liquid feces multiple time, pain in the lower right abdomen, the whole lower abdomen, reduced food absorption. Okay, and apart from that, what else is there? Malnutrition, also known as protein, energy, malnutrition, or PEM. Okay, it cause malnutrition means due to any reason where your body is not receiving adequate amount of protein, and not receiving adequate amount of protein will turn your body weak and have different symptoms coming up, and it causes different disease manifestation known as marasmus, kwashiorkor, which is very common in South and Southeast Asia, South America, West and Central Africa. These are the places where kwashiorkor and marasmus is there. So this is a part of PEM, also known as protein energy malnutrition. Okay, so what happens in these two, kwashiorkor or marasmus, MARAS, MUS, marasmus, and KWASHIORKOR, kwashiorkor. So in marasmus, it's found in infants less than a year age, in infants, and kwashiorkor is found in child more than a year age, but also in the children mostly. So marasmus has impaired growth and tissue replacement. It forms thin limb, dry, thin skin. The growth will be declined because no protein content is received by the body. The body weight will be reduced. Impaired growth and development of the brain. Why this is called? Generally, if the mother's milk is replaced at the early stage, very early stage, or mother having second pregnancy when older one is too young, generally this is the reason of causing marasmus kind of situation. While in kwashiorkor, again thin limbs, the muscle will be wasted because our skeletal muscles need protein to grow. They don't have protein to grow. Again, the brain function will not be that proper because the brain development will be halted. And what causes fat under the skin, which is not supposed to be present in the rest of the skin of the body. Generally, our fat is there beneath the skin. There is a adipose tissue layer which is totally separate in the belly. But if the fat is normally present beneath the skin of the rest of the part of the body, we call them edema or swelling. That is also seen. And again, why it is caused? Due to the low protein intake, low protein diet, low protein processivity by the body for some reason, and also replacement of mother's milk at the very early age. That's why mother's breast milk is a very important nutritious component every children need, every infant need at the early stage of the growth and development. Otherwise, the growth development will be halted, and severe illness can be, development of brain muscle in the newborn will be halted, and that is not good. So these are all different kinds of disorders. Apart from that, other disorders these days are inflammation of the intestinal tract, that is simply termed as IBS, irritable bowel syndrome, and inflammatory bowel disease, IBD. Most common type, don't have any cure these days, but these IBS and IBD problems are very, very common. Where irritable bowel syndrome is a situation which can be continuous feeling of diarrhea or constipation, or diarrhea constipation in repeated fashion. We call it IBS-D for IBS diarrhea type, or IBS-C, IBS constipation type. That actually leads to different problems. Diarrhea, and also related to which is spiked due to anxiety and stress, because the whole digestive system is very well regulated by hormones in our body. So due to this continuous stress and lack of physical activity, these hormonal pathways are somehow modified, and as a result of which it causes this continuous diarrhea or constipation or any other basic intestinal disorder. And it can also cause inflammation of the intestine, and this inflammation may be due to different reasons. And IBD is a little serious than IBS, but IBS is also very common. IBD is also there for immune system disorders, and also regarding any prolonged antibiotic treatment, or due to the toxic effect of any drug or toxic effect of any component that is there in the body due to some eating and food intake. But these are all the disorders of digestive system. And that concludes our understanding of the digestive system, human digestive system.